So this is what we'll be discussing today. We'll begin by understanding why we need DevOps. Everything exists for a reason, so we'll try to figure out that reason. We are going to see what are the various limitations of the traditional software delivery methodologies and how DevOps overcomes all of those limitations. Then we are going to focus on what exactly is the DevOps methodology and what are the various stages and tools involved in DevOps. And then finally, in the hands-on part, I'll tell you how you can create a Docker image, how you can build it, test it, and even push it onto Docker Hub in an automated fashion using Jenkins. So I hope we all are clear with the agenda. So let's move forward, guys, and we'll see why we need DevOps. So guys, let's start with the waterfall model. Now, before DevOps, organizations were using this particular software development methodology. It was first documented in the year 1970 by Royce and was the first public documented lifecycle model. The waterfall model describes a development method that is linear and sequential. Waterfall development has distinct goals for each phase of development. Now you must be thinking, why the name waterfall model? Because it's pretty similar to a waterfall. Now what happens in a waterfall, once the water has flowed over the edge of the cliff, it cannot turn back. The same is the case for waterfall development strategy as well. An application will go to the next stage only when the previous stage is complete. So let us focus on what are the various stages involved in waterfall methodology. So notice the diagram that is there in front of your screen. If you notice, it's almost like a waterfall, or you can even visualize it as a ladder as well. So first, what happens, the client gives requirements for an application. So you gather that requirement and you try to analyze it. Then what happens, you design the application, how the application is going to look like. Then you start writing the code for the application and you build it. When I say build it, it involves multiple things: compiling your application, unit testing, then even it involves packaging as well. After that, it is deployed onto the test servers for testing and then deployed onto the prod servers for release. And once the application is live, it is monitored. Now, I know this model looks perfect, and trust me, guys, it was at that time. But think about it. What will happen if we use it now? Fine, let me give you a few disadvantages of this model. So here are a few disadvantages. So first one is, once the application is in the testing stage, it is very difficult to go back and change something that was not well thought out in the concept stage. Now, what I mean by that, suppose you have written the code for the entire application, but in testing, there is some bug in that particular application. Now, in order to remove that bug, you need to go through the entire source code of the application, which used to take a lot of time, right? So that is one very big limitation of waterfall model. Apart from that, no working software is produced until late during the life cycle. We saw that when we are discussing about various stages of waterfall model. There are high amount of risk and uncertainty, which means that once your product is live, it is there in the market. Then if there is any bug or any downtime, then you have to go through the entire source code of the application again. You have to go through that entire process of waterfall model that we just saw in order to produce a working software again, right? So that's how it used to take a lot of time. There's a lot of risk and uncertainty. And imagine if you have upgraded some software stack in your production environment and that led to the failure of your application. Now to go back to the previous stable version used to also take a lot of time. Now, it is not a good model for complex and object-oriented projects, and it is not suitable for the projects where requirements are at a moderate to high risk of changing. So what I mean by that, suppose your client has given you a requirement for a web application today. Now, you have taken your own sweet time and you are in a condition to release the application, say, after 1 year. Now, after 1 year, the market has changed. The client does not want a web application. He's looking for a mobile application now. So this type of model is not suitable where requirements are at a moderate to high risk of changing. So there's a question popped on my screen. It is from Jessica. She's asking, so all the iteration in the waterfall model goes through all the stages? Well, there are no iteration as such, Jessica. First of all, it is not agile methodology or DevOps. It is waterfall model, right? There are no iterations. Once the stage is complete, then only it will be going to the next stage. So there are no iterations as such. If you're talking about the application when it is live, and then there is some bug or there is some downtime, then at that time, based on the kind of bug which is there in the application, suppose there might be a bug because of some flawed version of a software stack installed in your production environment, probably some upgraded version. Because of that, your application is not working properly. So you need to roll back to the previous stable version of the software stack in your production environment. So that can be one bug. Apart from that, there might be bugs related to the code in which you have to check the entire source code of the application again. Now, if you look at it, to roll back and incorporate the feedback that you have got is used to take a lot of time, right? So I hope this answers your question. All right, she's fine with the answer. Any other questions, any other doubts you have, guys, you can just go ahead and ask me. Fine. So there are no questions right now. So I hope we have understood what was the traditional waterfall model, what are the various limitations of this waterfall model. Now we are going to focus on the next methodology that is called the agile methodology. Now, agile methodology is a practice that promotes continuous iteration of development and testing throughout the software development lifecycle of the project. So the development and the testing of an application used to happen continuously with the agile methodology. So what I mean by that, if you focus on the diagram that is there in front of your screen, so here we get the feedback from the testing that we have done in the previous iteration. We design the application again, then we develop it, then again we test it, then we discover a few things that we can incorporate in the application. We again design it, develop it, and there are multiple iterations involved in development and testing of a particular application. So in agile methodology, each project is broken up into several iterations, and all iterations should be of the same time duration. And generally, it is between 2 to 8 weeks. And at the end of each iteration, a working product should be delivered. So this is what agile methodology in a nutshell is. Now let me go ahead and compare this with the waterfall model. Now, if you notice in the diagram that is there in front of your screen, so waterfall model is pretty linear and it's pretty straight, as you can see it from the diagram, that we analyze the requirements, we plan it, design it, build it, test it, and then finally we deploy it onto the prod servers for release. But when I talk about the agile methodology, over here, the design, build, and testing part is happening continuously. We are writing the code, we are building the application, we are testing it continuously. And there are several iterations involved in this particular stage. And once the final testing is done, it is then deployed onto the prod servers for release, right? So agile methodology basically breaks down the entire software delivery lifecycle into small sprints or iterations that we call it, due to which the development and the testing part of the software delivery lifecycle used to happen continuously. Let's move forward and we are going to focus on what are the various limitations of agile methodology. The first and the biggest limitation of agile methodology is that the dev part of the team was pretty agile, right? The development and testing used to happen continuously. But when I talk about deployment, then that was not continuous. There was still a lot of conflicts happening between the dev and the ops side of the company. The dev team wants agility, whereas the ops team wants stability. And there's a very common conflict that happens, and a lot of you can actually relate to it, that the code works fine in the developer's laptop, but when it reaches to production, there is some bug in the application, or it does not work in the production at all. So this is because of some inconsistency in the computing environment that has caused that, and due to which the operations team and the dev team used to fight a lot. There were a lot of conflicts, guys, at that time happening. So agile methodology made the dev part of the company pretty agile, but when I talk about the ops side of the company, they needed some solution in order to solve the problem that I've just discussed, right? So I hope you are able to understand what kind of a problem I'm focusing on. If you go back to the previous diagram as well, so over here, if you notice, only the design, build, and test, or you can say development, building, and testing part is continuous, right? The deployment is still linear. You need to deploy it manually onto the various prod servers. That's what was happening in the agile methodology, right? So the error that I was talking about, due to which our application is not working fine. I mean, once your application is live and due to some software stack in the production environment, it doesn't work properly. Now to go back and change something in the production environment used to take a lot of time. For example, you have upgraded some particular software stack, and because of that, your application is not at all working. It fails to work. Now, to go back to the previous stable version of the software stack, the operations team was taking a lot of time because they have to go through the long scripts that they have written on in order to provision the infrastructure. So let me just give you a quick recap of the things that we have discussed till now. We have discussed quite a lot of history. We started with the waterfall model. The traditional waterfall model, we understood what are its various stages and what are the limitations of this waterfall model. Then we went ahead and understood what exactly is agile methodology and how is it different from the waterfall model, and what are the various limitations of the agile methodology. So this is what we have discussed till now. Now we are going to look at the solution to all the problems that we have just discussed. And the solution is none other than DevOps. DevOps is basically a software development strategy which bridges the gap between the dev side and the ops side of the company. So DevOps is basically a term for a group of concepts that, while not all new, have catalyzed into a movement and are rapidly spreading throughout the technical community. Like any new and popular term, people may have confused and sometimes contradictory impressions of what it is. So let me tell you guys, DevOps is not a technology, it is a methodology. So basically, DevOps is a practice dedicated to the study of building, evolving, and operating rapidly changing systems at scale. Now, let me put this in simpler terms. So, DevOps is the practice of operations and development engineers participating together in the entire software lifecycle from design through the development process to production support. And you can also say that DevOps is also characterized by operations staff making use many of the same techniques as developers for their system work. I'll explain you that how is this definition relevant, because all we are saying here is DevOps is characterized by operations staff making use many of the same techniques as developers for their systems work. So when I will explain you infrastructure as code, you'll understand why I'm using this particular definition, right? So as you know that DevOps is a software development strategy which bridges the gap between the dev part and the ops side of the company and helps us to deliver good quality software in time. And how this happens? This happens because of various stages and tools involved in DevOps. So here is a diagram which is nothing but an infinite loop because everything happens continuously in DevOps, guys. Everything starting from coding, testing, deployment, monitoring, everything is happening continuously. And these are the various tools which are involved in the DevOps methodology, right? So not only the knowledge of these tools are important for a DevOps engineer, but also how to use these tools. How can I architect my software delivery lifecycle such that I get the maximum output, right? So it doesn't mean that, if I have a good knowledge of Jenkins or Git or Docker, then I become a DevOps engineer. No, that is not true. You should know how to use them. You should know where to use them to get the maximum output. So I hope you have got my point, what I'm trying to say here. In the next slide, I'll be discussing about various stages that are involved in DevOps. Fine, so let's move forward, guys, and we are going to focus on various stages involved in DevOps. So these are the various stages involved in DevOps. Let me just take you through all of these stages one by one. So starting from version control. So I'll be discussing all of these stages one by one as well, but let me just give you an entire picture of these stages in one slide first. So version control is basically maintaining different versions of the code. What I mean by that, suppose there are multiple developers writing a code for a particular application. So how will I know that which developer has made which commit at what time and which commit is actually causing the error? And how will I revert back to the previous commit? So I hope you're getting my point. My point here is how will I manage that source code? Suppose developer A has made a commit and that commit is causing some error. Now, how will I know that developer A has made that commit and at what time he made that commit and where in the code was that editing happened, right? So all of these questions can be answered once you use version control tools like Git, Subversion, etc., etc. We are going to focus on Git in our course. So then we have continuous integration. So continuous integration is basically building your application continuously. What I mean by that, suppose any developer made a change in the source code, a continuous integration server should be able to pull that code and prepare a build. Now, when I say build, people have this misconception of, only compiling the source code. It is not true, guys. It includes everything, starting from compiling your source code, validating your source code review, unit testing, integration testing, etc., etc., and even packaging your application as well. Then comes continuous delivery. Now, the same continuous integration tool that we are using, suppose Jenkins. Now, what Jenkins will do once the application is built, it will be deployed onto the test servers for testing to perform, user acceptance tests or end user testing that you call it. There will be using tools like Selenium, right, for performing automation testing. And once that is done, it'll be then deployed onto the prod servers for release, right? That is called continuous deployment. And here we'll be using configuration management and containerization tools. So this is basically to provision your infrastructure, to provision your prod environment. And let me tell you guys, continuous deployment is something which is not a good practice because before releasing your product in the market, there might be multiple checks that you want to do before that, right? There might be multiple other testings that you want to do. So you don't want this to be automated, right? That's why continuous deployment is something which is not preferred. After continuous delivery, we can go ahead and manually use configuration management tools like Puppet, Chef, Ansible, and SaltStack, or we can even use Docker for a similar purpose, and then we can go ahead and deploy it onto the prod service for release. And once the application is live, it is continuously monitored by tools like NagOS or Splunk, which will provide the relevant feedback to the concerned teams, right? So these are various stages involved in DevOps, right? So now let me just go back to clear if there are doubts. So this is how various stages are scheduled, various jobs are scheduled. So we have Jenkins here, we have a continuous integration server. So what Jenkins will do, the moment any developer makes a change in the source code, it will take that code and then it will trigger a build using tools like Maven or Ant or Gradle. Once that is done, it will deploy it onto the test servers for testing, for end user testing using tools like Selenium, JUnit, etc. Then what happens, it will automatically take that tested application and deploy it onto the prod servers for release, right? And then it is continuously monitored by tools like NagOS, Splunk, ELK, etc., etc. So Jenkins is basically heart of DevOps lifecycle. It gives you a nice 360-degree view of your entire software delivery lifecycle. So with that UI, you can go ahead and have a look how your application is doing currently, right? Where in which stage it is in right now, testing is done or not. All those things you can go ahead and see in the Jenkins dashboard, right? So there might be multiple jobs running in the Jenkins dashboard that you can see, and it gives you a very good picture of the entire software delivery lifecycle, guys. Don't worry, I'm going to discuss all of these stages in detail when we move forward. So we are going to discuss each of these stages one by one, starting from source code management, or even called as version control. Now, what happens in source code management? There are two types of source code management approaches. One is called centralized version control, and another one is called the distributed version control. So source code management. Now imagine there are multiple developers writing a code for an application. If there is some bug introduced, how will we know which commit has caused that error, and how will I revert back to the previous version of the code? In order to solve these issues, source code management tools were introduced. And there are two types of source code management tools. One is called centralized version control and another is distributed version control. So let's discuss the centralized version control first. So centralized version control system uses a central server to store all the files and enables team collaboration. It works in a single repository to which users can directly access a central server. So this is what happens here, guys. So every developer has a working copy, the working directory. So the moment they want to make any change in the source code, they can go ahead and make a commit in the shared repository, right? And they can even update their working copy by, pulling the code that is there in the repository as well. So the repository in the diagram that you're noticing indicates a central server that could be local or remote, which is directly connected to each of the programmer's workstation, as you can see. Now, every programmer can extract or update their workstation with the data present in the repository, or can even make changes to the data or commit it in the repository. Every operation is performed directly on the central server or the central repository. Even though it seems pretty convenient to maintain a single repository, but it has a lot of drawbacks. But before I tell you the drawbacks, let me tell you what advantage we have here. So first of all, if anyone makes a commit in the repository, there will be a commit ID associated to it, and there will always be a commit message. So you know which person has made that commit and at what time, and where in the code basically, right? So you can always revert back. But let me now discuss few disadvantages. First of all, it is not locally available, meaning you always need to be connected to a network to perform any action. It is always not available locally, right? So you need to be connected with some sort of network basically. Since everything is centralized, in case of the central server getting crashed or corrupted, it will result in losing the entire data of the project, right? So that's a very serious issue, guys. And that is one of the reasons why industries don't prefer centralized version control system. Let's talk about the distributed version control system now. Now, these systems do not necessarily rely on a central server to store all the versions of the project file. So in distributed version control system, every contributor has a local copy or clone of the main repository. As you can see, I'm highlighting with my cursor right now. That is, everyone maintains a local repository of their own, which contains all the files and metadata present in the main repository. As you can see then the diagram as well, every programmer maintains a local repository on its own, which is actually the copy or clone of the central repository on their hard drive. They can commit and update their local repository without any interference. They can update their local repositories with new data coming from the central server by an operation called pull, and affect changes to the main repository by an operation called push, right? Operation called push from their local repository. Now, you must be thinking what advantage we get here. What are the advantages of distributed version control over the centralized version control? Now, basically, the act of cloning an entire repository gives you that advantage. Let me tell you how. Now, all operations apart from push and pull are very fast because the tool only needs to access the hard drive, not a remote server. Hence, you do not always need an internet connection. Committing new change sets can be done locally without manipulating the data on the main repository. Once you have a group of change sets ready, you can push them all at once. So what you can do is you can actually commit to your local repository, which is there in your local hard drive. You can commit the changes that you want in the source code. You can, once review it, and then once you have quite a lot of change sets ready, you can go ahead and push it onto the central server as well. If the central server gets crashed at any point of time, the lost data can be easily recovered from any one of the contributors' local repositories. This is one very big advantage. Apart from that, since every contributor has a full copy of the project repository, they can share changes with one another if they want to get some feedback before affecting the changes in the main repository as well. So these are the various ways in which, distributed version control system is actually better than the centralized version control system. So we saw the two types of source code management systems, and I hope you have understood it. We are going to discuss one source code management tool called Git, which is very popular in the market right now. Almost all of the companies actually use Git. For now, I'll move forward and we're going to focus on a source code management tool, a distributed version control tool that is called as Git. Now, before I move forward, guys, let me make this thing clear. So when I say version control or source code management, it's one and the same thing. Let's talk about Git now. Now, Git is a distributed version control tool that supports distributed nonlinear workflows by providing data assurance for developing quality software, right? So it's a pretty tough definition to follow, but it'll be easier for you to understand with the diagram that is there in front of your screen. So for example, I am a developer and this is my working directory, right? Now what I want to do is I want to make some changes to my local repository because it is a distributed version control system. I have my local repository as well. So what I'll do, I'll perform a git add operation. Now because of git add, whatever was there in my working directory will be present in the staging area. Now you can visualize the staging area as something which is between the working directory and your local repository, right? And once you have done git add, you can go ahead and perform git commit to make changes to your local repository. And once that is done, you can go ahead and push your changes to the remote repository as well. After that, you can even perform git pull to add whatever is there in your remote repository to your local repository and perform git checkout to add everything which was there in your local repository to your working directory as well. All right, so let me just repeat it once more for you guys. So I have a working directory here. Now, in order to add that to my local repository, I need to first perform git add that will add it to my staging area. Staging area is nothing but an area between the working directory and the local repository. After git add, I can go ahead and execute git commit, which will add the changes to my local repository. Once that is done, I can perform git push to push the changes that I've made in my local repository to the remote repository. And in order to pull the changes which are there in the remote repository to the local repository, you can perform git pull and finally git checkout that will be added to your working directory as well. And git merge is also a pretty similar command. Now, before we move forward, guys, let me just show you a few basic commands of Git. So I've already installed Git in my CentOS virtual machine. So let me just quickly open my CentOS virtual machine to show you a few basic operations that you can perform with Git. CentOS virtual machine, and I've told you that I've already installed Git. Now, in order to check the version of Git, you can just type in here git hyphen hyphen version, and you can see that I have 2.7.2 here. Let me go ahead and clear my terminal. So now let me first make a directory and let me call this as edureka hyphen repository. And I'll move into this edureka repository. So first thing that I need to do is initialize this repository as an empty Git repository. So for that, all I have to type here is git init, and it will go ahead and initialize this empty directory as a local Git repository. So it has been initialized now. As you can see, initialize empty Git repository in home edureka hyphen repo.git. All right then. So over here, I'm just going to create a file, a Python file. So let me just name that as edureka.py. And I'm going to make some changes in this particular file. So I'll use gedit for that. I'm just going to write in here a normal print statement. Welcome to edureka. Close the parenthesis, save it, close it. Let me clear my terminal. Now, if I hit an ls command, so I can see that edureka.py file is here. Now, if you can recall from the slides, I was telling you in order to add a particular file or a directory into the local Git repository, first I need to add it to my staging area. And how will I do that? By using the git add command. So all I have to type here is git add and the name of my file, which is edureka.py. And here we go. So it is done now. Now, if I type in here git status, it will give me the files which I need to commit. So this particular command gives me the status. Status as in it will tell me what all files I need to commit to the local repository. So it says one new file has been created, that is edureka.py in the stage, and it is present in the staging area. And I need to commit this particular file. So all I have to type here is git commit hyphen m and the message that I want. So I'll just type in here first commit, and here we go. So it is successfully done now. So I've added a particular file to my local Git repository. So now what I'm going to show you is basically how to deal with the remote repositories. So I have a remote Git repository present on GitHub. So I've created a GitHub account. So the first thing that you need to do is create a GitHub account, and then you can go ahead and create a new repository there. And then I'll tell you how to add that particular repository to your local Git repository. Let me just go to my browser once. Let me just zoom it a bit and yeah. So this is my GitHub account, guys. And what I'm going to do is I'm first going to go to this repositories tab and I'm going to add one new repository. So I'll click on new. I'm going to give a name to this repository. So whatever name that you want to give, you just go ahead and do that. Let me just write here git hyphen tutorial hyphen DevOps, whatever name that you feel like. Just go ahead and write that. I'm going to keep it public. If you want any description, you can go ahead and give that. And I can also initialize it with a README. Create repository, and that's all you have to do in order to create a remote GitHub repository. Now, over here, you can see that there's only one readme.md file. So what I'm going to do, just going to copy this particular SSH link, and I'm going to perform git remote add origin, and the link that I've just copied, I'll paste it here, and here we go. So this has basically added my remote repository to my local repository. Now what I can do is I can go ahead and pull whatever's there in my remote repository to my local Git repository. For that, all I have to type here is git pull origin master, and here we go. So it is done now. As you can see that I've pulled all the changes. So let me clear my terminal and hit an ls command. So you'll find readme.md present here, right? Now what I'm going to show you is basically how to push this edureka.py file onto my remote repository. So for that, all I have to type here is git push origin master, and here we go. So it is done now. Let me just go ahead and refresh this particular repository, and you'll find edureka.py file here. Let me just go ahead and reload this. So you can see edureka.py file where I've written welcome to Edureka. So it's that easy, guys. Let me clear my terminal now. So I've covered few basics of Git. So let's move forward with this DevOps tutorial, and we are going to focus on the next stage, which is called continuous integration. So we have seen few basic commands of Git. We saw how to initialize an empty directory into a Git repository, how we can, add a file to the staging area, and how we can go ahead and commit it in the local repository. After that, we saw how we can push the changes in the local repository to the remote repository. My repository was on GitHub. I told you how to connect with that remote repository, and then how even you can pull the changes from the remote repository, right? So all of these things we have discussed in detail. Now let's move forward, guys, and we are going to focus on the next stage, which is called continuous integration. So continuous integration is basically a development practice in which the developers are required to commit changes to the source code in a shared repository several times a day, or you can say more frequently. And every commit made in the repository is then built. This allows the teams to detect the problems early. So let us just understand this with the help of the diagram that is there in front of your screen. So here we have multiple developers which are writing code for a particular application, and all of them are committing code to a shared repository, which can be a Git repository or a Subversion repository. From there, the Jenkins server, which is nothing but a continuous integration tool, will pull that code the moment any developer commits a change in the source code. The moment any developer commits a change in the source code, Jenkins server will pull that, it will prepare a build. Now, as I have told you earlier as well, build does not only mean compiling the source code. It includes compiling, but apart from that, there are other things as well. For example, code review, unit testing, integration testing, packaging your application into an executable file. It can be a WAR file or it can be a jar file. So it happens in a continuous manner. The moment any developer commits a change in the source code, Jenkins server will pull that, prepare a build, right? So this is called as continuous integration. So Jenkins has various tools in order to perform this. So it has various tools for development, testing, and deployment technologies. It has well over 2,500 plugins. So you need to install that plugin, and you can just go ahead and trigger whatever job you want with the help of Jenkins. It is originally written in Java, right? And let's move forward, and we are going to focus on continuous delivery now. So continuous delivery is nothing but taking continuous integration to the next step. So what are we doing? In a continuous manner or in an automated fashion, we are taking this build application onto the test server for end user testing or unit or user acceptance test, right? So that is basically what is continuous delivery. So let us just summarize continuous delivery again. The moment any developers makes a change in the source code, Jenkins will pull that code, prepare a build. Once build is successful, it will take the build application and Jenkins will deploy it onto the test server for end user testing or user acceptance test. So this is basically what continuous delivery is. This happens in a continuous fashion. So what advantage we get here? Basically, if there's a build failure, then we know which commit has caused that error and we don't need to go through the entire source code of the application. Similarly, for testing, even if any bug appears in testing as well, we know which commit has caused that error, and we can just go ahead and have a look at that particular commit instead of checking out the entire source code of the application. So basically this system allows the teams to detect problems early, right? As you can see it from the diagram as well. Now, if you want to learn more about Jenkins, I'll leave a link in the chat box. You can go ahead and refer that. And people who are watching it on YouTube can find that link in the description box below. Now we're going to talk about continuous deployment. So continuous deployment is basically taking the application, the build application that you have tested and deploying that onto the prod servers for release in an automated fashion. So once the application is tested, it will automatically be deployed onto the prod servers for release. Now, this is something not a good practice, as I've told you earlier as well, because there might be certain checks that you need to do in order to release your software in the market, or you might want to market your product before that. So there are a lot of things that you want to do before deploying your application. So it's not advisable or a good practice to, actually automatically deploying your application onto the prod service for release. So this is basically continuous integration, delivery, and deployment. Any questions you have, guys, you can ask me. All right, so Jagrati wants me to repeat it once more. Sure, Jagrati, I'll do that. Let's start with continuous integration. So continuous integration is basically committing the changes in the source code more frequently, and every commit will then be built using a Jenkins server, right? Or any continuous integration server. So this Jenkins, what it'll do, it'll trigger a build the moment any developer commits a change in the source code. And build includes your compiling, code review, unit testing, integration testing, packaging, and everything. So I hope you're clear with what is continuous integration. It is basically continuously building your application. The moment any developer commits a change in the source code, Jenkins will pull that code and prepare a build. Let's move forward. And now I'm going to explain you continuous delivery. Now in continuous delivery, the package that we have created here, the var or the jar file or the executable file, Jenkins will take that package and it will deploy it onto the test server for end user testing. So this kind of testing is called the end user testing or user acceptance test, where you need to deploy your application onto a server, which can be a replica of your production server, and you perform end user testing, or you call it user acceptance test. For example, in my application, if I want to check all the functions, right, functional testing, if I want to perform functional testing of my application, I'll first go ahead and check whether my search engine is working. Then I'll check whether people are able to log in or not. So all those functions of a website when I check, or an application when I check, is basically after deploying it onto a server, right? So that sort of testing is basically what is your functional testing, or what I'm trying to refer here. Next up, we are going to continuously deploy our application onto the prod servers for release. So once the application is tested, it will be then deployed onto the prod servers for release. And I've told you earlier as well, it is not a good practice to deploy your application continuously or in an automated fashion. So guys, we have discussed a lot about Jenkins. How about I show you how Jenkins UI looks like and how you can download plugins and all those things. So I've already installed Jenkins in my CentOS virtual machine. So let me just quickly open my CentOS virtual machine. So guys, this is my CentOS virtual machine again, and over here I've configured my Jenkins on localhost port 8080/Jenkins, and here we go. Just need to provide the username and password that you have given when you were installing Jenkins. So this is how Jenkins looks like, guys. Over here there are multiple options. You can just go and play around with it. Let me just take you through a few basic options that are there. So when you click on new item, you'll be directed to a page which will ask you to give a name to your project. So give whatever name that you want to give. Then choose the kind of project that you want, right? And then you can go ahead and provide the required specifications, required configurations for your project. Now, when I was talking about plugins, let me tell you how you can actually install plugins. So you need to go to Manage Jenkins, and here's a tab that you'll find Manage Plugins. So in this tab, you can find all the updates that are there for the plugins that you have already installed. In the available section, you'll find all the available plugins that Jenkins support. So you can just go ahead and search for the plugin that you want to install, just check it, and then you can go ahead and install it. Similarly, the plugins that are installed will be found in the Install tab, and then you can go ahead and check out the Advanced tab as well. So this is something different. Let's not just focus on this for now. Let me go back to the dashboard. And this is basically one project that I've executed, which is called Edureka Pipeline. And this blue color symbolizes that it was successful. The blue color ball means it was successful. That's how it works, guys. So I was just giving you a tour to the Jenkins dashboard. We'll actually execute the practical as well. So we'll come back to it later. But for now, let me open my slides and we'll proceed with the next stage in the DevOps lifecycle. So now let's talk about configuration management. So what exactly is configuration management? So now let me talk about few issues with the deployment of a particular application or provisioning of the servers. So basically what happens, I have built my application, but when I deploy it onto the test servers or onto the prod servers, there are some dependency issues because of which my application is not working fine. For example, in my developer's laptop, there might be some software stack which was upgraded, but in my prod and in the test environment, they're still using the outdated version of that software stack, because of which the application is not working fine. This is just one example. Apart from that, what happens when your application is live and it goes down because of some reason? And that reason can be you have upgraded a software stack. Now, how will you go back to the previous stable version of that software stack? So there are a lot of issues with the admin side of the company, the ops side of the company, which were removed with the help of configuration management tools. So, before admins used to write these long scripts in order to provision the infrastructure, whether it's the test environment or the prod environment or the dev environment. So they used to write those long scripts, right, which was prone to error. Plus, it used to take a lot of time. And apart from that, the admin who has written that script, no one else can actually recognize what's the problem with it if you have to debug it. So there are a lot of problems that were there with the admin side or the ops side of the company, which were removed by the help of configuration management tools. And one very important concept that you guys should understand is called infrastructure as code, which means that writing code for your infrastructure. That's what it means. Suppose if I want to install LAMP stack on all of these three environments, whether it's dev, test, or prod, I'll write the code for installing LAMP stack in one central location, and I can go ahead and deploy it onto dev, test, and prod. So I have the record of the system state present in my one central location. Even if I upgrade it to the next version, I still have the record of the previous stable version of the software stack, right? So I don't have to manually go ahead and write scripts and deploy it onto the nodes. This is that easy, guys. So now let me just focus on few challenges that configuration management helps us to overcome. First of all, it can help us to figure out which components to change when requirements change. It also helps us in redoing an implementation because the requirements have changed since the last implementation. And very important point, guys, that it helps us to revert to a previous version of the component if you have replaced with a new but the flawed version. Now, let me tell you the importance of configuration management through a use case. Now, the best example I know is of New York Stock Exchange. A software glitch prevented the NYSE from trading stocks for almost 90 minutes. This led to millions of dollars of loss. A new software installation caused the problem. That software was installed on 8 of its 20 trading terminals, and the system was tested out the night before. However, in the morning, it failed to operate on the 8 terminals. So there was a need to switch back to the old software. Now, you might think that this was a failure of NYSE's configuration management process, but in reality, it was a success. As a result of proper configuration management, NYSE recovered from that situation in 90 minutes, which was pretty fast. Had the problem continued longer, the consequences would have been more severe, guys. So I hope you have understood its importance. Now let's focus on various tools available for configuration management. So we have multiple tools like Puppet, Chef, Ansible, and SaltStack. I'm going to focus on Puppet for now. So Puppet is a configuration management tool that is used for deploying, configuring, and managing servers. So let's see what are the various functions of Puppet. So first of all, you can define distinct configurations for each and every host and continuously check and confirm whether the required configuration is in place and is not altered on the host. So what I mean by that, you can actually define distinct configurations. For example, in my one particular node, I need this software stack. In another node, I need this software stack. So I can, define distinct configurations for different nodes and continuously check and confirm whether the required configuration is in place and is not altered. And if it is altered, Puppet will revert back to the required configurations. This is one function of Puppet. It can also help in dynamic scaling up and scaling down of machines. So what will happen if in your company, there's a big billion day sale, right? And you're expecting a lot of traffic. So at that time, in order to provision more servers, probably today your task is to provision 10 servers and tomorrow you might have to provision say 100 VMs, right? So how will you do that? You cannot go ahead and do that manually by writing scripts. You need tools like Puppet that can help you in dynamic scaling up and scaling down of machines. It provides control over all of your configured machines, so a centralized change gets propagated to all automatically. So it follows a master slave architecture in which the slaves will poll the central server for changes made in the configuration. So we have multiple nodes there which are connected to the master. So they will poll, they will check continuously, is there any change in the configuration happened in the master? The moment any change happen, it will pull that configuration and deploy it onto that particular node. I hope you're getting my point. So this is called pull configuration. In push configuration, the master will actually push the configurations onto the nodes, which happens in Ansible and SaltStack, but does not happen in Puppet and Chef. So these two tools follow pull configuration, and Ansible and SaltStack follows push configuration, in which these configurations are pushed onto the nodes. And here in Chef and Puppet, the nodes will pull that configurations. They keep on checking the master at regular intervals. And if there is any change in the configuration, it will pull it. Now, let me explain you the architecture that is here in front of your screen. So that is basically a typical Puppet architecture in which what happens, you can see that there's a master slave architecture. Here is our Puppet master and here is our Puppet slave. Now, the functions which are performed in this architecture, first the Puppet agent sends the fact to the Puppet master. So this Puppet slave will first send the fact to the Puppet master. Facts, what are facts? Basically, they are key value data pairs. It represents some aspects of slave state, such as its IP address, uptime, operating system, or whether it's a virtual machine, right? So that's what basically facts are. And the puppet master uses a fact to compile a catalog that defines how the slaves should be configured. Now, what is a catalog? It is a document that describes the desired state for each resource that puppet master manages on a slave. Then what happens? The puppet slave reports back to the master, indicating that configuration is complete and which is also visible in the puppet dashboard. So that's how it works, guys. So let's move forward and talk about containerization now. So what exactly is containerization? So I believe all of you have heard about virtual machines. So what are containers? Containers are nothing but the lightweight alternatives to virtual machines. So let me just explain that to you. So we have Docker containers that will contain the binaries and libraries required for a particular application. And that's when we call it, we have containerized a particular application, right? So let us focus on the diagram that is there in front of your screen. So here we have host operating system, on top of which we have Docker engine. We have a no guest operating system here, guys. It uses the host operating system. And we are learning two containers. Container one will have application one and its binaries and libraries. The container two will have application two and its binaries and libraries. So all I need in order to run my application is this particular container or this particular container, because all the dependencies are already present in that particular container. So what is basically a container? It contains my application. The dependencies of my application, the binaries, libraries required for that application is there in my container. Nowadays, if you must have noticed that when you want to install some software, you'll actually get ready to use Docker containers, right? That is the reason, because it's pretty lightweight when you compare it with virtual machines, right? So let me discuss a use case how you can actually use Docker in the industry. So suppose you have some complex requirements for your application. It can be a microservice, it can be a monolithic application, anything. So let's just take microservice. So suppose you have complex requirements for your microservice, so you have written the Docker file for that. With the help of this Docker file, I can create a Docker image. So Docker image is nothing but, a template. You can think of it as a template for your Docker container, right? And with the help of Docker image, you can create as many Docker containers as you want. Let me repeat it once more. So we have written the complex requirements for a microservice application in an easy to write Docker file. From there, we have created a Docker image, and with the help of Docker image, we can build as many containers as we want. Now that Docker image, I can upload that onto Docker Hub, which is nothing but a Git repository of Docker images. You can have public repositories, you can have private repositories there. And from Docker Hub, any team, be it staging or production, can pull that particular image and prepare as many containers as they want. So what advantage we get here? Whatever was there in my developer's laptop, right? The microservice application, the guy who has written that, and the requirements for that microservice application. So that guy is basically a developer, and because he's only developing the application. So whatever is there in my developer's laptop, I have replicated in my staging as well as in my production. So there's a consistent computing environment throughout my software delivery lifecycle. I hope you're getting my point. So guys, let me just quickly brief you again about what exactly are Docker containers. So just visualize container as actually a box in which your application is present with all its dependencies, except the box is infinitely replicable. Whatever happens in the box stays in the box unless you explicitly take something out or put something in. And when it breaks, you will just throw it away and get a new one. So containers usually make your application easy to run on different computers. Ideally, the same image should be used to run containers in every environment stage from development to production. So that's what basically Docker containers are. So guys, this is my CentOS virtual machine here again, and I've already installed Docker. So the first thing is I need to start Docker. For that, I'll type systemctl start Docker. Give the password, and it has started successfully. So now what I'm going to do, there are few images which are already there in Docker Hub, which are public images. You can pull it at any time you want. All right, so you can go ahead and run that image as many times as you want. You can create as many containers as you want. So basically, when I execute the command of pulling an image from Docker Hub, it will try to first find it locally, whether it's present or not. And if it is present, then it's well and good. Otherwise, we'll go ahead and pull it from the Docker Hub. So right, so before I move forward, let me just show you how Docker Hub looks like. If you have not created an account on Docker Hub, you need to go and do that, because for executing a use case, you have to do it. That's free of cost. So this is how Docker Hub looks like, guys. And this is my repository that you can notice here, right? I can go ahead and search for images here as well. So for example, if I want to search for Hadoop images, which I believe one of you asked, so you can find that we have Hadoop images present here as well, right? So these are nothing but few images that are there on Docker Hub. So I believe now I can go back to my terminal and execute few basic Docker commands. So the first thing that I'm going to execute is called Docker images, which will give the list of all the images that I have in my local system. So I have quite a lot of images, you can see, right? This is the size and all those things when it was created, the image, this is called the image ID, right? So I have all of these things displayed on my console. Let me just clear my terminal. Now what I'm going to do, I'm going to pull an image, right? So all I have to type here is docker pull. For example, if I want to pull an Ubuntu image, I'll just type in here docker pull Ubuntu, and here we go. So it is using default tag latest. So tag is something that I'll tell you later, but yeah, it will provide the default tag latest all the time. So it is pulling from the Docker Hub right now because it couldn't find it locally. So download is complete. It is currently extracting it. Now, if I want to run a container, all I have to type here is docker run -it Ubuntu, or you can type the image ID as well. So I am in the Ubuntu container. So I've told you how you can see the various Docker images. I've told you how you can pull an image from Docker Hub and how you can actually go ahead and run a container. And we're going to focus on continuous monitoring now. So continuous monitoring tools resolve any system errors. You know, what kind of system errors? Low memory, unreachable server, etc., etc., before they have any negative impact on your business productivity. Now, what are the reasons to use continuous monitoring tools? Let me tell you that. It detects any network or server problems. It can determine the root cause of any issue. It maintains the security and availability of the services and also monitors and troubleshoots server performance issues. It also allows us to plan for infrastructure upgrades before outdated system cause failures, and it can respond to issues at the first sign of problem. And let me tell you guys, these tools can be used to automatically fix problems when they are detected as well. It also ensures IT infrastructure outages have a minimal effect on your organization's bottom line and can monitor your entire infrastructure and business processes. So what is continuous monitoring? It is all about the ability of an organization to detect, report, respond, contain, and mitigate the attacks that occur on its infrastructure or on the software. So basically, we have to monitor the events on the ongoing basis and determine what level of risk we are experiencing. So if I have to summarize continuous monitoring in one definition, I will say it is the integration of an organization's security tools. So we have different security tools in an organization. The integration of those tools, the aggregation, normalization, and correlation of the data that is produced by the security tools, right? Now what happens? The data that has been produced, the analysis of that data based on the organization's risk goals and threat knowledge and near real-time response to the risk identified is basically what is continuous monitoring. And there's a very good saying, guys, if you can't measure it, you can't manage it. I hope you know what I'm talking about. Now, there are multiple continuous monitoring tools available in the market. We're going to focus on NagOS. NagOS is used for continuous monitoring of systems, applications, services, and business processes in the DevOps culture, right? And in the event of failure, NagOS can alert technical staff of the problem, allowing them to begin remediation process before outages affect business processes, end users, or customers. So with NagOS, you don't have to explain why an unseen infrastructure outage affect your organization's bottom line. So let me tell you how it works. So I'll focus on the diagram that is there in front of your screen. So NagOS runs on a server usually as a daemon or a service. It periodically runs plugins residing on the same server. They contact hosts or servers on your network. So you can see it in the diagram as well. It periodically runs plugins residing on the same server. They contact hosts or servers on your network or on the internet. Hosts or servers which can be locally present or it can be remotely present as well. One can view the status information using the web interface. You can also receive email or SMS notification if something happens. So NagOS daemon behaves like a scheduler that runs certain scripts at certain moments. It stores the results of those scripts and will run other scripts if these results change. Now, what are plugins? So plugins are compiled executables or scripts that can be run from a command line to check the status of a host or service. So NagOS uses the results from the plugins to determine the current status of the host and services on your network. So what happens actually in this diagram? NagOS server is running on a host and plugins interact with local or remote hosts, right? Now these plugins will send the information to the scheduler, which displays that in the GUI. That's what is happening, guys. All right, so we have discussed all the stages. So let me just give you a quick recap of what all things we have discussed. First, we saw what was the methodology before DevOps. We saw the waterfall model, what were its limitations. Then we understood the agile model and the difference between the waterfall and the agile methodology, and what were the limitations of agile methodology. Then we understood how DevOps overcomes all of those limitations and what exactly is DevOps. We saw the various stages and tools involved in DevOps, starting from version control. Then we saw continuous integration, then we saw continuous delivery, then we saw continuous deployment. Basically, we understood the difference between integration, delivery, and deployment. Then we saw what is configuration management and containerization, and finally explained continuous monitoring, right? So in between, I was even switching back to my virtual machine where I have few tools already installed, and I was telling you a few basics about those tools. Now comes the most awaited topic of today's session, which is our use case. So let's see what we are going to implement in today's use case. So this is what we'll be doing. We have Git repository, right? So developers will be committing code to this Git repository, and from there, Jenkins will pull that code and it will first clone that repository. After cloning that repository, it will build a Docker image using a Docker file. So we have that Docker file, we'll use that to build an image. Once that image is built, we are going to test it and then push it onto Docker Hub. As I've told you, what is Docker Hub is nothing but like a Git repository of Docker images. So this is what we'll be doing. Let me just repeat it once more. So developers will be committing changes in the source code. So the moment any developers commits a change in the source code, Jenkins will clone the entire Git repository. It will build a Docker image based on the Docker file that we'll create. And from there, it will push the Docker image onto the Docker Hub. This will happen automatically with a click of a button. So what all tools we'll be using? We'll be using Git, Jenkins, and Docker. So let me just quickly open my virtual machine and I'll show you there. So what our application is all about. So we are basically creating a Docker image of a particular application and then pushing it onto Docker Hub in an automated fashion. And our code is written in the GitHub repository. So what is that application? So it's basically a Hello World server written with Node. So we have main.js. Let me just go ahead and show you on my GitHub repository. Let me just go back. So this is how our application looks like, guys. We have main.js, right? Apart from that, we have package.json for our dependencies. Then we have Jenkins file and Docker file. Jenkins file, I'll explain it to you what we are going to do with it. But before that, let me just explain you a few basics of Docker file and how we can build a Docker image of this particular very basic Node.js application. First thing is writing a Docker file. Now, to be able to build a Docker image with our application, we will need a Docker file. Yeah, right. You can think of it as a blueprint for Docker. It tells Docker what the contents and parameters of our image should be. So Docker images are often based on other images. But before that, let me just go ahead and create a Docker file for you. So let me just first clone this particular repository. So let me go to that particular directory first. It's there in downloads. Let me unzip this first. Unzip DevOps-tutorial. And let me hit an ls command. So here is my application present. So I'll just go to this particular DevOps-tutorial-master and let me just clear my terminal. So let us focus on what all files we have. We have Docker file. Let's not focus on Jenkins file at all for now, right? We have Docker file, we have main.js, package.json, readme.md, and we have test.js. So I have a Docker file with the help of which I'll be creating a Docker image, right? So let me just show you what I've written in this Docker file. Before this, let me tell you that Docker images are often based on other images, right? For this example, we are basing our image on the official Node Docker image. So this line that you're seeing is basically to base our application on the official Node Docker image. This makes our job easy and our Docker file very, very short, guys. So the hectic task of installing Node and its dependencies in the image is already done in our base image. So we'll just need to include our application. Then we have set a label maintainer. I mean, this is optional. If you want to do it, go ahead. If you don't want to do it, it's still fine. There's a health check, which is basically for Docker to be able to tell if the server is actually up or not. And then finally, we are telling Docker which port our server will run on, right? So this is how we have written the Docker file. Let me just go ahead and close this. And now I'm going to create an image using this Docker file. So for that, all I have to type here is sudo docker build /home/edureka downloads DevOps-tutorial, basically the path to my Docker file. And here we go. You need to provide the sudo password. So it has started now. It is creating an image for me, the Docker image, and it is done now. It has successfully built, and this is my image ID. right? So I can just go ahead and run this as well. So all I have to type here is docker run -it and my image ID, and here we go. So it is listening at port 8000. Let me just stop it for now. So I've told you how you can create an image using Dockerfile, right? Now what I'm going to do, I'm going to use Jenkins in order to clone a Git repository, then build an image, and then perform testing and finally pushing it onto Docker Hub, my own Docker Hub profile. All right. But before that, what we need to do is we need to tell Jenkins what our stages are and what to do in each one of them. For this purpose, we'll write Jenkins pipeline specification in a Jenkins file. So let me show you how the Jenkins file looks like. I'll just click on it. So this is what I've written in my Jenkins file, right? So it's pretty self-explanatory. First, I've defined my application. I mean, just clone the repository that I have, then build that image. This is the tag that I'm using, edureka1, which is username, and edureka is the repository name, right? So build that image, then test it. So we're just gonna print test passed, and then finally push it onto Docker Hub, right? So this is the URL of Docker Hub, and my credentials are actually saved in Jenkins in Docker Hub credentials. So let me just show you how you can save those credentials. So go to the credentials tab. So here you need to click on system and click on global credentials. Now over here, you can go ahead and click on update, and you need to provide your username, your password, and your Docker Hub credential ID, that whatever you're gonna pass there, right? So let me just type the password again. All right. Now we need to tell Jenkins two things: where to find our code and what credentials to use to publish the Docker image, right? So I've already configured my project. Let me just go ahead and show you what I've written there. So the first thing is the name of my project, right? Which I was showing you when you create a new item over there, there's an option called where you need to give the name of your project, and I've chosen pipeline project. So if I have to show you the pipeline project, you can go to new item, and this is what I've chosen, that the kind of project. And then I've clicked on build triggers. So basically this will poll my SCM, the source code management repository, after every minute. Whenever there's a change in the source code, it'll pull that and it will repeat the entire process after every minute. Then advanced project options are selected, the pipeline script from SCM here. Either you can write pipeline script directly or you can click on pipeline script from source code management. That kind of source code management is Git. Then I've provided the link to my repository, and that's all I have done. Now, when I scroll down, there's nothing else. I can just click on apply and save. So I've already built this project once. So let me just go ahead and do it again. All right, so it has started. First, it will clone the repository that I have. You can find all the logs once you click on this blue color ball. And you can find the logs here as well. So once you click here, you'll find it over here as well. And similarly, the logs are present here also. So now we have successfully built our image. We have tested it. Now we are pushing it onto Docker Hub. So we have successfully pushed our image onto Docker Hub as well. Now, if I go back to my profile and I go to my repository here, so you can find the image is already present here. I've actually pushed it multiple times. So this is how you will execute the practical. It was very easy, guys. So let me just give you a quick recap of what all things we have done. First, I told you how you can write a Docker file in order to create a Docker image of a particular application. So we were basing our image on the official node image of present in the Docker Hub, right, which already contains all the dependencies, and it makes our Docker file looks very small. After that, I built an image using that Docker file. Then I explained you how you can use Jenkins in order to automate the task of cloning a repository, then building a Docker image, testing the Docker image, and then finally uploading that onto the Docker Hub. We did that automatically with the help of Jenkins. I told you where you need to provide the credentials, what are tags, how you can write the Jenkins file. The next part of the use case is different teams, be it staging or production, can actually pull the image that we have uploaded onto Docker Hub and can run as many containers